This is the solution video to the Unit 3 homework, the intermediate level. The question asks us to compose a fractal using an initial line segment and then adding 3 more line segments to it to create this kind of a shape. So the fractal is very similar to the Koch curve. It just adds 1 more line segment, but it's still dividing the initial line segment, this one, into 3 pieces and then inserting this additional piece. So the Hausdorff dimension for this shape would be log 5 over log 3, which is 1.46 roughly. Now let's go to the NetLogo model and construct it. So I'm opening up the Koch curve NetLogo model, press setup and then step, and you can iterate this Koch curve a number of times. Now go to the code button. Here we are in the code tab of the program. Let's scroll down to the to iterate procedure, and this is where the Koch curve is inputted, and we're going to change this to our new shape, which is similar, so we'll keep some of it, but let's change this 60 to 90 and then change this right to 90, and then we need to do all that again. So I'm going to cut and paste that piece, and then our final leg is left 90. Let's see if that works. I'm going to check the code to see if it's okay. The code looks okay, so I'm going to go back to the interface and run the program, press setup and step, and iterate a few times. And it looks like something's wrong. What's actually happening is that the shape is going off the view. It's larger than our view window. So go to settings, and we can increase the y coordinate of our view size, maximum py core. Let's make that 90. Press OK. And now let's see if it works. Setup, step. I have to scroll down to see the entire shape. Iterate a few times. And it looks like it's correct. The next step of the homework will be to define this shape again in the box counting program, and then check its dimension using box counting and compare that to the Hausdorff dimension. Here I have the box counting dimension NetLogo model open. Press the button labeled Koch curve, and then press the button iterate. And we can see our familiar Koch curve shape iterating a number of times. This program also allows you to analyze the box counting dimension for an individual shape, which we'll do in a second. But first, let's set up the Koch curve button to now be our homework button. So I'm going to drag the cursor across the button labeled Koch curve, then right click and go to edit. And then we'll change the display name Koch curve to HW-3 for homework 3. And we also need to change this line, set fractal example, to be, instead of Koch curve, HW3. Make sure you save the parentheses, HW-3, and then press OK. Now we have a button set up for our homework shape, so we need to now change that procedure to be the correct shape. So go to the code button, scroll down to the setup procedure, and in this line where it says if fractal example equals Koch curve, we'll change the Koch curve to HW-3. And then scroll down to the Koch curve procedure here, and again we'll change this Koch curve to HW-3, and we need to reprogram our directions. So again, this is similar to the first part of the homework. We'll turn left 90, then here we'll have to turn right 90, and then we need to do all that again. So I'm going to cut and paste this section, turn right 90 again. This gets us back to the original line segment, and then at the very end we'll turn left 90 and check that. Go back to the interface, press homework 3 and iterate. And now we can see our homework shape iterating. So I'm going to iterate that 3 times. Then go down to the box counting controls and press box counting setup button, and then box counting go. And we can see the program performing a box count of our new shape. And we'll let that run for a little while to do it at least a half a dozen iterations or so. It's running kind of slow, so I'm going to try and speed it up a little bit. See if this helps. And we can see the box counting plot is plotting all the points that each run generates. So it's counting the number of boxes and comparing that to the size of each box. And I'm going to stop that by going to Tools and scrolling down to Halt. And then we'll press Find Best Fit Line. And this is showing us that we're getting a box counting dimension of 1.254, and we can compare that to our Hausdorff dimension of 1.465 and see that it's relatively accurate, but not probably as good as we would like. So we could change our initial box length and also change our increment and play with that and see if we can get a tighter fit for our distribution. But I'll leave that to you to experiment. And this is the conclusion of the intermediate homework for Unit 3.